From the previous lecture, we know that the operating line of the flash distillation column is given by y star equal to f minus 1 over f multiplied by x star plus xf over f. And we are also given that the small f here represented by f is equal to V, or the amount of vapor, divided by the amount of feed. In this case, the amount of vapor is 60 mole and the amount of feed is 100. So to give you F is equal to 0.6. From the equation also, we can find or solve the operating line by solving the amount of XF. And XF here is given by FA divided by F, which is FA is 70 divided by 100 to give you 0.7. Okay, so we can now solve for the y-intercept of the operating line, which is XF over small f is equal to 0.7 divided by 0.6. So that will give you a value where you can solve for the y-intercept of the equilibrium curve. So the data for equilibrium curve should be found from the equilibrium data between a mixture of heptane and octane at 30 degrees Celsius and 1 atmospheric pressure for the operating condition. If we were to sketch the diagram, so we just sketch a graph, okay, where the maximum value for the fraction is 1.0. This is for the liquid, and for the vapor the maximum is also 1.0. And then you need to draw the 45-degree line, okay, and then you need to have your equilibrium data plotted, and then you just sketch. Okay, so you just plotted the equilibrium data that you get from the information. Okay, and then you need to recognize your feed amount. So the feed amount is the feed mole fraction is XFA, which is 0.7. Next thing you need to do is to draw the vertical line until it reaches the 45-degree line. Okay, and then now you have to determine the value for the y-intercept of your operating line, which is the XF over small f, which is 0.7 over 0.6, which is 7 over 6. So let's estimate the value. So let's say you just extend the line, and this is where you have 7 over 6. Okay, so you just draw a straight line to connect between this y-intercept of operating line with the intercept of 45-degree line and the mole fraction of the feed. So now the green line here represents the operating line for the given flash. Okay, so by looking at this, actually you can find now, so this is where you're gonna get your y star. Okay, and then draw a vertical line downward. This is where you get your x star. So the x star and y star here represent the more volatile component, which is your heptane, and both phases are in equilibrium. So the equilibrium composition is given by x star A, y star A. Okay, so you solve the problem. So now it's your turn to draw this graph on the graph paper.